Assalamu alaikum students. This is Sir Abdul Samad Khan, and today we are going to start our new chapter of mathematics, that is logarithms for grade 8 matriculation. So let's get started. Introduction. Logarithms were introduced by the great Muslim mathematician Abu Muhammad Musa al-Khwarizmi. Later on in the 17th century, John Napier developed the concept of logarithm further and prepared tables for it. In these tables, the base e was used. E is an irrational number whose approximate value is 2.71828 and so on. The properties of the number e were found by the great mathematician Euler. So the first letter of his name is used to denote this number. In 1631, Professor Henry Briggs developed the tables with the base 10. This is a brief introduction about the chapter of logarithms. Okay, so we are going to start our first topic from the chapter of logarithm, that is the scientific notations. So what are the scientific notations? Scientific notations is a very short way to write very large and very small numbers. For example, if we see in this example, we have the number 0.000057, and as we know that this is a very small value, so it can be written in the scientific notation as 5.7 times 10 raised to the power of minus 5. Okay, in the next example, as we have seen that it is a very large value, 1 2 3 4 5 6 7 8 9. There are 9 digits in this value, and it can be written in the scientific notation as 1.2345678 times 10 raised to the power of 8. If you observe in example number 1, the exponent or the power is negative, that is minus 5 over here, and in example number 2, exponent is positive, that is 8 over here. Okay, let us learn when the exponent or the power is taken positive and when negative with the help of some examples. Okay, so we are now going to learn about some rules and when we are going to take the powers or the exponents positive and when negative. Number 1, whenever the value starts from any number other than 0, the exponent should always be taken positive, and when any value starts from 0, the exponent is taken negative. Number 2, in case of negative exponents, you just have to count the numbers of zeros before and after the decimal. The number of times 0 comes in any value is actually the negative exponent. Number 3, if any value starts from any number other than 0, you just have to count the values before the decimal and then less one from it. The number of values remaining is actually the positive exponent. For example, if we see in this example, we have the value 123.4. In the above value, there are 3 numbers before the decimal. So if we subtract 1 from 3, we will get 2, which is actually the positive exponent. Let us learn this with some examples. Okay, write the following in scientific notations. We have given our first question as 5643.9, and we have asked to convert it in the scientific notation. So this is the scientific notation for it. So we are going to learn that whenever the value starts from any number other than 0, the power should always be taken positive. Okay, so if we just count the values before decimal, we clearly see that there are 4 values before it. So we just have to subtract 1 from it, and 4 minus 1 is equal to 3, and that is actually the exponent, number 1. And number 2, the main thing is that the point in the scientific notation should always be placed after the first value. Okay. Second one, 0.00342. As we have discussed in the previous slide, that whenever the value starts from 0, the exponent or the power will always be negative, and the number of times 0 comes in any value is actually the exponent. So if we see that there is a 0 before decimal point and there are 2 zeros after the decimal point, so if we count all these three, we will get 3. So this is the scientific notation for this value, and since we have 3 zeros, so the negative 3 will be the exponent of this base. Okay, the third example is 1, 2, 3 and 4. If you see over here that there is not a decimal point mentioned in this value, so what we have to do, if any value doesn't have the decimal point, it always contains the point at the end of the number. Okay, that means there is a decimal point after 4. Okay, so this case is just similar to the first one. We just have to count the values before the decimal point. That means we have 4 values before the decimal point, so we have to subtract 1 from it, and then we have the answer of 3 as the exponent. So this is the scientific notation of these 3 values. Okay, definition of logarithms. Let a, b and c are 3 real numbers. If a is equal to b to the power of c, then the logarithm of a to base b is c, and it is written as log to the base of b of a will be equal to c. What does it mean? It means that if we apply the power c to base b, we will get a. Okay, this form is known as the exponential form, the power form. Okay, and this one, whereas this form is known as the logrammatic form. This form is known as the exponential form, and this one is known as the logrammatic form. Let us learn how to convert the exponential form to the logarithmic form, or vice versa, with the help of some examples. Vice versa means the reverse of the previous statement. Okay, example number 1. Write the following in logrammatic form. As we see over here, we have given the exponential form of 3 to the power of 4 will equal to 81, and we have asked to convert it in the logrammatic form. So what we have to do, we just have to write like in this way. Okay, let me explain this. We have to put the base under the logarithm, number 1, and then with the logarithm we have to write the number of which we are going to calculate the logarithm, and on the right hand side we have to put the power. This is the basic structure of converting into the logarithmic form. So if we see over here, 3 is a base and 4 is the exponent or the power, and 8 is actually the number of which we are going to calculate the logarithm. So we can write like this, that log to the base of 3 of 81 is equal to 4. It means that if we take this base and if we apply this power on it, we will get this answer. Okay, example number 2. 10 to the power of minus 3 is equal to 0.001. So what will be the logarithmic form of this? This is the logarithmic form. So you just have to use the basic structure, like put the base under the logarithm, number 1, that is 10, and place this value or the number with the logarithm and place the power on the right hand side, that is minus 3. This is simply the logrammatic form of this exponential form, and it states that if we take this base and apply this power on it, we will get this answer. Simple. Okay, example number 2. In this example, write the following in exponential form. It is the reverse of the previous one. Over here we have given the logarithmic form and we have asked to convert it in the form of exponent. So what we have to do, we just have to write like this base. If we take this base and apply this power on it, we will get this answer. That means if we take 5 square, it will be equal to 25, and this is the exponential form of it. Number 2. If we take this base and apply this power, we will get this answer. So the exponential form for this question will be 100 to the power of 0 will equal to 1. So that's all from today's video. Inshallah, we will meet in the next video with some other topics from the chapter of logarithms. So till the next time, thank you so much for watching, and Allah Hafiz.